Hello everyone. So today we are going to implement this high performance grass generation system. So each individual grass blade here is generated through code. So there are no pre-imported measures at work here. So therefore with this method you can achieve very good performance compared to conventional grass systems that you have in Unreal. So let me play and show you the comparison. So here you get a performance level closer to 100 FPS and yeah, 90, 100. So and you note that there is no 𝐂𝐿𝐼𝐼 here, so all the grass blades to the end that I have added is visible, and still we have pretty good performance. We have the shadows as well and also the wind animation too. And on the other side of the landscape I have placed normal grass. So here now you can see performance drops to about 75 FPS. I'm pretty sure there are techniques to further optimize this, and but what I want to do is what I want to research is how to implement a high performance grass system, and what are the advantages of doing that, and how far we can push that system to get the results we need. Obviously this one looks realistic because this is a mega scan grass, and here also we have the shadows, and it does have a realistic texture applied to it as well. We can actually apply a texture also here. I still haven't implemented that part. We only have just a yellowish tip and a green color. That's all I have added here. So the important point here is achieving this performance level. So actually what is I wanted to try this method because of this Ghost of Tsushima video. So in this video they explained that they have used a procedural system which generate individual grass blade through the code and rendering in GPU. So that's why I wanted to try a similar system inside Unreal and see how far I can go. So maybe you should give it a watch to this. You should check this video as well. I'll leave the link in the description. So they explain how they have created the grass system for Ghost of Tsushima, and as you can see this game has beautiful grass with the high density compared to most other games. So yeah, now let's see how to implement this. Maybe not as good as Ghost of Tsushima, but at least to get started with a basic version using a technique somewhat similar to that. Alright, so before we get started, I'd like to remind you that you can download any project that I have done in my channel from the Patreon page. So once you become a member, you can download any project without a limit. So that would help me to continue what I do in my channel. So feel free to check it out. I'll leave the link in description below. To the date, there are over thousands of projects, and for each project you can download the project files and you can use them in your games. Okay, so here is a blank landscape. Now let me create a folder. CM grass. Here let's create a new blueprint using the type actor CLM grass system. Okay, now I'll place this in the middle of this landscape. Let me go to the top view. If I make it 0, it's there. Let me enable snapping. Okay, roughly the middle now. Right, now let me open this blueprint. So here let's start with adding few variables. I'll add a 2D int point, grass tile count. I'll make it a int point structure so we can give a x value and a y value. So I'll make it 2 by 2. So we will have 4 grass tiles. I'll make it public, and then another variable, let's call it tile size. This could be a float, and then another float variable, grass density. So this would be how much grass for a unit distance, something like that. Let's figure these variables out as we implement the system and do modifications and refactorings as necessary. So here I'll define a custom event. Let's call it generate grass tiles. Okay, now I'll make this call in editor so that we can press this button to call that function. So the first task is identifying the area that we need to spawn grass. So generate grass, not spawning, because we are not just spawning static measures or anything. So here let's get the tile count and let's run 2 for loops. So it should be something like this. Imagine this is our landscape, and then we place the grass generator here. So if we have 2 by 2, then we will need tiles, grass tiles like this, like this, 2 by 2, since it becomes 4. And in this case, since this is the origin, the coordinates of these tiles would be, let's say this one -1 -1, this one, sorry, if this is x positive and if this is y positive, this one would be 1 1, this one would be 1 -1, this one would be -1 -1, so like that. You get the idea, right? Now here let me divide this by 2, and then, as I said, we need 2 for loops, not for each loop, for loop, like this. So the starting index would be, let me split this. So for y, starting index would be this number multiplied by -1 to get the minus side. I'll take that as the first index and then directly this value as the second index. So if this is 2 by 2, then it would be starting from -1 and go until +1. So actually that would give us 3 tiles, but that's fine, that's fine. So let's get the system to work first. Another for loop, same as before. This is the last index, and then multiplied by -1. Okay. Now we need to identify the center of each tile. So how can we do that? So from here we get the x coordinate, and here we get the y coordinate. So if I make a vector using these two numbers, x and y, and then multiply this with, let me convert this to a float, and multiply this with the tile size, and this is in local space. So if I add actor location, then this would be the center of the, maybe not the center, maybe a corner. So I'll just say origin of that tile. So to visualize this, I'll draw a debug line, start in here and end 200 units above. Duration, I'll keep it for 10 seconds. Thickness 10. Okay, I say this cross demo just in case it crashes. I want to save. So I don't see anything. Okay. Oh, actually we have a line here, and we have kept tile size to 0. So what if I use 5000 and gross density, I'm not sure actually, I'll leave it 0.1 for now. Maybe we need this higher, 1000. Okay, now generate cross tiles. Yeah, now here we have these lines. So yeah, I increased the thickness to demonstrate it clearly. So as you can see, we are going to have 3 tiles this way and 3 tiles this way. Maybe I should subtract 1 before the division. Yeah, why? No, I'll forget about that issue for now. All we need is having grass. So, oh wait, too much. Okay, all right. So these are going to be the origins of each tile. So now let's add another function. Generate cross tile. Oh, it should be a function. What I added is a graph. So this one needs an input. I'll call it origin. Should be a vector. And now we need to run another 2 for loops to identify positions on the surface to generate grass meshes. So basically to identify vertex points. So for that, first we need to identify the gap between two grass blades. So how can we calculate that? Yeah, if I get the grass density and the tile size, let's just think of density as the number of tiles, a number of grass blades, maybe a proportional number that is a number that is proportional to the number of grass blades we need inside a tile. So if I just divide this from the density, wait, no, not divide, yeah, division is fine, yeah, and I'll promote this to a local variable. I'll call it gap. So this would give us gap between two grass blades. Okay, and not return, reroute node. I'll collapse this to keep it clean. Calculate gap. Right, now let's add a for loop. One is going from x in x direction and another one is going in y direction. So what's the default value we have? Tile size 0. I'll make it, I did make it 5000. And density, I think I did assign some values here. Yeah, density, I'll make it 500. So the gap would be 10 units between two grass blades, maybe 250, so 20. Okay, now starting position, starting index and end, how do we calculate that? So we have the tile size and divide this by 2, and just like before, I'll multiply with -1. That would be the start. We have to truncate because these are float values, that's fine. And the last index, last index should be directly this value, right? And the same should go to the second for loop because we have squares as tiles, so the dimensions are same. Okay, now again here we have x and then y. So just like before, let's make a vector using these two, and then multiply this with the gap so that we can get the positions for each point, and then I'll add the origin, this input origin, get origin, so this would be the location well, not exact location, only xy. Z location we need to find out, perhaps using a line trace. So let's do a line trace because we need to find where the ground is. Line trace by channel and start point here. I'll add 2000 upward, that's the start, and 2000 downward. That's the end. So if I enable debug type here, since we are going to get a lot of line traces, that would cause a massive hit, as I understand. Therefore, grass density, let me make it 50 and test this. So here, now we don't need this, we do need this debug line. No, we don't really need this. I'll call generate grass tile using this location. Now we should see a lot of line traces. See, it got stuck. Should use gap actually. Again wrong. Sorry. We should use density. Oh, too much. But that logic is correct, yeah. So here, if I make it 10, now we can see the entire area is covered. So this is the area that we are going to draw grass blades. So since I have used grass density 10 here, this is going to be easier for drawing these lines, but I'm going to disable it because we need more than 10. So, but for now, let's work with 10. Now here, if we get a hit, say branch, then let me break this hit result and we get a location. This is one vertex point in our grass mesh. So I'll have another local variable, vertices, and it should be a vector, of course. Right, now this location, make it vertices, add, oops, this should be a array. Add. So since these are local variables, we don't have to worry about cleaning things up or clearing out the vertices when we try to render the next tile. So this will work fine, right? And then so this is the first point, and I'll add another variable. So this is the base of the grass. Let's add another variable, grass height, and there should be a float, not an array, just a single value, and public. I'll make it maybe not 100. Yeah, maybe 100. Let's see. And then to this point, add the grass height, and that's gonna be our second vertex point. Add right, and this is the top point, and we need another point too, so on the base. So for now I'll use this same point and add in x direction. I'll have another variable, grass width. Let's make it perhaps 20. Connect it here. Okay. Now this is going to be our third vertex point. Right. To our this array. Okay, now we have 3 vertices. So I'll add another local variable, vertex count. And this should be an integer. So we need, so at the end, we are going to create a mesh using a procedural mesh. I'll make it the root. So for that, here, once we complete this loop, under the procedural mesh, we can create mesh section. For this we need vertices and triangles are essential. Other things it's not necessary for us to connect, as I remember from the procedural terrain generation. So, but we need triangles, so another local variable, triangles, and we already have the vertices here. So to define triangles, let me collapse this section and I'll name it add vertices, and here now let's add the triangles. So get the triangles, add. So obviously first point gonna be the first vertex that we added, so that's gonna be the index of that's gonna be the vertex count. A little explanation, let me delete this. So imagine these are the vertices that we added. This is the base point and another base point. This is the first vertex and the second vertex and the third vertex here. Second one means this one that we added height, and third one means this one that we added an x offset. So this is first one, second one, third one. And in order to render a triangle, we need to give the order of vertices. So first I'm gonna add this and this and this. So this will give us I'm terrible at drawing. A triangle like this. Okay, so this would be visible only from one direction. So in order to make it visible from the other direction, we need to give a triangle, define a triangle in this direction too. So how do we define a triangle? Keep adding these vertices in the order we want. So first one is vertex count, of course, and the next one is vertex count plus 1, the top one, and the third one is this one. No, let's use this, vertex count plus 2. Okay, right. And as I said, this triangle will be visible from only one direction, but that's okay for now for testing. Now once we are done with creating triangles, let's try adding a mesh section. Here we would need another variable to define the mesh section index. So cross mesh section index. I'll make this public so that we can see how this changes. And when we start rendering grass, here we will have to set it to 0. No, just set it to 0. And if we try this function for the second time, we need to delete the already existing meshes. So clear all mesh sections. Okay, now let's see, hope this will not freeze. Do we see anything? No. All right, so at the end of adding these triangles, where were we? Here. After adding these triangles, we need to increment the vertex count. So get this and add 3. Otherwise we would be keep adding 0 1 2 0 1 2 0 1 2. So there will be only one triangle overlapped multiple times. And set. Okay, now let's see. Okay, oh, I see grass blades, but they are over here. Okay, I guess we missed something with regarding the adding location of the actor, right? So inside here, when we add vertices, I'll subtract the actor location, because the reason is this procedural mesh is we need to give a relative location. So get that vector location. Let's not worry about the rotation for now. Right, now if I generate, yeah, we have the grass blades here, but for only one tile, because I think I didn't increment this grass mesh index. We should do that here. Increment. Okay, now we should get a lot of grass. Just to see compared to the character how large the grass blade's gonna be. Yeah. Okay, the scale is fine, but we need to increase the density. So now I'll disable this line trace debug mode because that's gonna cost performance and lag the function. Now let's try 100. Okay, let's give it a color. This green material, it's nothing special, just a green material. Here let's set material. Element index is this. Same. I'll assign that material. So this we should get green. No. Why not? It's not connected. Okay, see, now we have green, and this is how it looks compared to the character. So, and yeah, as you can see, the grass is only visible from this side but not from this side. So that's because the triangle is only visible from one side. So to prevent that, what we should do is here let me collapse this at triangles. So let's add 3 more triangles with counterclockwise. So that means, let me duplicate this. And the starting vertex would be same as before, but the middle one would be the third one, and the third one would be the second one. Right, now the grass should be visible from both directions. Okay, nice. So the next step is all the grass blades looks identical. So now let's add a variation to the height. So grass height variation, and I'll make it not, this is 100, so let's say 20. So it will be either be 80. The way I want to do it is it should be either be 80 or 120, maybe 30, a little more variation. So then when we add the vertex, this height, second vertex, this height, I'll add a random value between range. So random float in range, minimum would be the grass height variation. Can I move it next to grass? Okay. Maximum is grass height variation, minimum is grass height variation multiplied by -1. Okay, now we should get a variation in height. Let's see. Yeah, it's not the same height now anymore. See, just check this. There is a variation now. Okay, but now the orientation of grass blades. So everything, all the grass blades are facing aligned in this, what's this direction? X-axis. So to prevent that, we can do something like this. Here, let's add a grass width variation too. No, we might not need that. So let's do the same thing that we did here. So instead of grass width, let's add a random float. Minimum is grass width -1 multiplied by -1. Maximum is grass width, and use that for X. And I'll duplicate this. The reason to duplicate is because sometimes I think this value generated here is cached and reused. I want to prevent that. I do use the same value for Y as well. Now we should see some difference. Let's see. Yeah, now they are not facing the same direction. They are rotated around the place. See? And also some are thick, some are thin. Maybe we should reduce the width. Okay, now we see much variation, but also the location is still looks like it's in a grid. So let's add a location offset 2. For that, what we need to do is let's add another variable, location offset variation. It should be a float, and same as before, I'll use 20. Let's add it here. The same logic. Location offset variation. This is the min and max. Add to X. I forgot to connect max here. Add to y, and I think we should have we should push the first vertex below the ground a little bit, so maybe minus 10, because sometimes if there is a slope in the landscape, one vertex might hang in air. So okay. Oh wait, this is subtract, so this should be plus, otherwise it's gonna go up. Okay, looks fine, but not nice. So height variation, maybe no, width 5. It looks like the width doesn't change. Oh wait, it looks like this location offset variation is affecting the width for some reason. Yeah, okay, so maybe, alright, maybe we should promote this to a local variable. Base vertex. So let's do it this way. So my assumption here may be wrong. I thought this value is cached and reused, but yeah, it's fine. Now let's see. Right. Okay, width. Now let's increase this. Right. Maybe we should have a minimum width, otherwise this may not look good. So, or maybe this is fine. When we have when we increase the density, this should be good enough. This should be okay. And location offset, let's try 20. Yeah, it's better now. See, no more, it doesn't look anymore like it's in a grid. Great. So I increased the density to 300 and rendered again, generated again. Now this is how it looks. So yeah, we are getting there. So I think we should stop this episode here and continue from the next episode, because we have already taken about 50 minutes. So next time we will work on how to add UVs and how to add grass wind and also material modifications to make it look better, and also some optimizations to this generation system, because at the now it tries to generate everything in one go. Instead of that, I want to implement a system that it renders chunk by chunk, so the editor does not freeze during the generation time. And how to make them persistence, how to save them, a lot of things that we need to discuss, but one episode is not enough, so let's look into those things in the next episode. So thanks for watching. As always, updated project files will be available here in the Patreon page for you to download, and link would be in the description below. So see you in another episode. Goodbye.